Alright, hello. I am confident we are very close to getting this joint working. So, what I did was, I went and I looked up I gotta go in my history, and I don't want to share that. I've also been buying Christmas presents, so not a good thing to share. Anyways, I found a Verlet integration. An example of Verlet integration. How loud is this music? Oh, it's good. So what I'm going to do is I'm going to try to apply this. So the super interesting thing when I was going over this earlier is that this is the exact same thing as my code. Calculates the length minus the rest length into the difference value. The one thing it does that I thought was correct, and it actually does, is it multiplies it by half. So one thing I had wrong is that this is actually an iterative algorithm. You need to iterate it infinite, like there's some times it can never solve the joints. But the more times I'll iterate it and step, the more times it'll solve. So I'm pretty confident I can actually apply this. So I believe what I have to do is take this out of the body loop and do it in steps. And I'm guessing it'll work with the velocity like I'm doing, because as long as I take the velocity into this, to account with this. So I don't know if I want to put this here, or maybe I'll put it after right here. Alright, so most of this joint code is going to be the same. The only difference is, as well, as I'm going to do a step loop. So first I'll try just 2 steps. This is 1 step more. Alright, so I just want this to be 1, I believe, just the delta time. I don't know if the mass is going to work with this. I'm just going to do 1 to start. But yeah, I don't know if this is actually going to work with the mass. Hopefully it will. Anyways, minus the joint radius times the joint strength. This is supposed to actually be 0.5. Alright, that should do it. So actually, I don't know if I want to hang it up now and actually test it swinging, just to see if it actually... Whoa. Okay. Apparently this only works, or at least I'm thinking this only works if you do it with the Verlet integration, where you do it with the what is it called? It's doing it with the position, not with the velocity.
They're here.
Oh my god, it's not saving the velocity.
Aliens.
Oh my god.
Extraterrestrials.
There we go.
It doesn't matter what you call them. They've arrived.
5 divided by length. Yeah, that should be good. Okay, first of all, actually, let's try this with less. Much less than 10. Okay, so our goal is to try and get these held together. Let's try 100 steps. Let's see if this actually works.
They're here.
Oh my god, it works! Oh, look at it! Oh my god. Oh, yes! I figured it out. Oh, yes! Oh my god, that's amazing. There we go. So there's joints. So now I can work on optimizing this and fixing it. Oh my god. I actually didn't think this would work this easy. Holy cow. So I was looking at this algorithm too, and I was like, oh yeah, this is going to be super bad because it's iterative and it has to loop over it like 100 times. So first of all, actually, let me test just 10 times. So yeah, 10 times still leaves a pretty big gap, but okay. Let's say even if I do have to do 100 times to get decent quality with this, this algorithm is basically adding up the position. It's just a whole bunch of adding and multiplying. Okay, I gotta check actually if this takes mass into account. Realistically, this probably doesn't have to take mass into account. I can like I do not. I don't think. I don't know. I'll have to see. Anyways, what I was saying is all of this is a whole bunch of adding and multiplying, and just super simple instructions. It is perfect for optimizing with SSE and AVX. And here's the whole other thing. I'm not planning on having a whole bunch of these joints either, but anyways, let's say if I have to do it 100 times, I can look at doing this with SSE and AVX instructions. Anyways, let's see if it works with different masses. Okay, so let's make one of these way bigger. So this is going to make the one that I'm pulling way stronger, or heavier, which also makes it stronger to pull. Wait, is it? Because this is actually being harder to pull. Wait. No, yeah, it is the top I'm pulling. Should have bigger mass. Oh wait, is it doing the mass wrong then? Wait, okay. Maybe I can't. Maybe clamping it breaks it. So let me think. If it's pulling it 10 to 1, so 10. Okay, if this is 10 bigger than that. It gets pulled towards it. No, this is backwards, yeah. Anyways, I'll try it without clamping. Oh yeah, here we go. I wonder what it's doing when it's lagging that little bit. I wonder if it's like the collision stepping or what. Anyways, it's working pretty well. Yeah, okay, I think that's wrong. I think it does have to limit it. Is that the limit on it? This seems too fast. Yeah, I guess. Anyways, that is awesome. Okay, let's try it with a bit bigger. Oh, that works amazing. That is awesome. Oh, I'm so happy with this. Okay. So one of the things, though, that I want to figure out is what exactly would I do for optimizing this? And oh my god, I just started this stream, and I was expecting this to take at least an hour, and this is basically solved now. Shit. I'm not ready to optimize this in refactor yet either. I'm just gonna think about how to, like, this right now is not optimizable because I'm basically looping through the whole actual rigid body. So I think I'm gonna go back to this joint system method I have, where I built like an actual joint system structure where I can just loop through each system, and then like the more connected ones, like, or the bigger systems that have more particles in them are going to need more steps in this. So like I want the step function here to be configurable for each joint system as well. So this current way of looping through isn't going to work. But yeah, if I have them all in a joint system 2D, then if I wanted to do SSE instructions, I would have to have, so this is a fused multiply and add right here, but that requires AVX. I'm just going to do this with SSE, so this would be a multiply and add and subtract, but this would be on a vec2, which wouldn't be so I think I'm just like, so what you have to do with SSE to make it optimized as well is you have to load the memory, because SSE works with vector 4s. One of the things of that is it has to be aligned to that, which is 16 bytes, 4 bytes for each float. 4 floats, so 16 bytes. So you have to align the memory you're going to be reading and writing in that. So that's going to be part of my joint system structure if I want to do this. And the other thing I'm considering right now is it even worth optimizing this when joint systems probably aren't even going to be a huge part of any of the games that I do. The one thing is, though, if I ever do want to do like some nice simulations, this would be such a good thing to have optimized. So this right here technically is a vector 4. this is 4 right here, but then the issue is once you go into these operations right here that are only vector 2 instructions. So yeah, the actual easiest way to optimize this with SSE would be to have each of these, maybe not even the position, just the velocities stored in the SSE aligned arrays, because the velocities are the main part that are worked on here. And then you would work on 2 of the joint connections at once. So SSE would actually only benefit where there's more than 2 objects in the joint system. So I want to try and figure out an approach. Oh yeah, and then if I'm extending it to 3D, that's not going to apply. Okay, I just want to do a test here as well. What if lowering the iterations, but I increase this 0.5? Because in my tests before, I was able to get that like up to 1. So let me see what 0.6 does. Let me see if that holds it close together. That still works. Let's try 1. Interesting. I think it is holding to get better together. So that might be a nice and interesting option to add. It's actually a scale of the joint strength. And then that would give me an alternative to optimizing it. Awesome. Man, I was not expecting to get this working. Shit, what am I gonna do now? Yeah, it definitely made it way stronger. The joint connection, that's cool. Okay. Oh, physics is awesome. Alright, maybe I will go through here and do all of this. I was not expecting to do this today, god damn it. Alright. Gonna be a lot of deleting code. One of the other things I'm thinking about is if I'm gonna set up these joint systems like this with a separate object that I manually do, because another thing that I could do that may be a bit slower to initialize but much easier to use afterwards is if I just had this joint object. Yeah, that would actually, nah. I'm gonna do the separate joint system structure, because then actually I can store all these variables as well. Oh yeah, I also need to implement the onCollision function. I also need to think if there's a better way than having a bool right here of his collider. because that boolean is aligned to 4 bytes, and that bugs the shit on me that there's 3 wasted bytes. Whatever. Now I'm actually starting to think about the 1-button jam too, now that I have this working. So I think I'm going to actually get the renderer and everything, make sure it's all working perfectly. And I'm going to use that for rendering the car and the course. I think the course, though, I'm going to do a procedural hills. And then I'm going to add an option. I'm going to implement a custom collider system into the physics 2D so that I can do like custom hills and stuff for the game. Yeah, I still haven't even optimized these. I don't know what I'm talking about doing SSE down here when I haven't optimized that. I guess I can delete all this old code too. Actually, this will probably be what I loop through for this. Ooh, okay. So the other thing here is, I don't want each of these to have the same radius, and I'm not going to do a viscosity system anymore. So I'm going to have a body joint. I'm going to have a joint object, so this list is actually going to be a list of the joints. Want any other options besides radius? Yeah, I could have strength as well. I wonder how I could do elasticity with this. Oh, and this would be so much better actually if I had it. I'm just going to do this as a fixed list. Alright, awesome. So that joint system is all set up. I think one thing I could do is to optimize this, because instead I'm going to have to read the object pointer from this and then the position from that, is if I instead had an array of the positions and velocities. I don't know though. If you only have a count, how do you allocate the joint system before knowing how many joints you need? If you had capacity in a count, it would be more flexible. Yeah, I was going to use a dynamic list there before, but every single case I'm going to use a joint system. I'm going to have a fixed number of joints, and then I can just like reallocate is exactly what my list what the dynamic list uses when it expands. So I'm never seeing a case where I'm going to be constantly expanding a joint system. And if there is a case where I'm constantly expanding a joint system, I'm going to like pre-allocate like a giant count, and then I'm just going to like scale the count up as I need it. Now that would be premature optimization. Right now this is good. Now instead of having to loop over every rigid body, I just loop through the joint systems, and then I can also scale the steps for each different joint system. So certain ones can be lower quality than others. I'm not going to use like any of this old code, so mostly rewrite this. Alright. So we need to read the radius, strength. Main engine C with physics, masses and stuff, but no joints. Nice. I find it really fun to try and do this. I've been trying to do joints for like 2-3 days now. Actually, maybe even more. I haven't really been counting. I might not even need to read these actually. That's premature optimization. Can I post the link? Go for it. Nice. I crashed my PC the other day trying to do 10,000 particles in my physics engine. That was an interesting way of ending my stream. Yeah, so this is going to read the object, and it's going to read the position. It seems like a waste reading those pointers each time in this loop. Doesn't sound like much for a modern PC, and it kind of is, because at 50 times a second, so each of those 10,000 particles, like at minimum with a good acceleration structure, has to test the collisions with 10 other particles. And that's at like best case scenario. Sometimes that's like 100, and if you have no acceleration structure, it's 10,000 testing against 10,000 particles. But even against 10 other particles, you've got 100,000 collision tests to do 50 times a second. You don't do sweep and clear or anything. I do what's it called, distance tracing. So it takes large steps when it's moving quickly, and it never, like, collision, it can't pass through walls, as long as I don't set the precision too low. I don't think sweep and clear is even fast. Isn't sweep and clear isn't that the slow way where you just sweep through? Physics, sweep and clear. Oh my god, it's not coming up with anything. Game dev, physics, collisions. Yeah, I thought the sweep test, yeah, you can see here, our collision detection always ON2, which is what I was saying, 10,000 times 10,000. Yeah, so I don't use sweep and clear because you need to move the object by, to stop it from passing through, you need to move the object at most the size of the object's smallest radius, or the collider's smallest radius. So it doesn't work with really small objects like bullets efficiently, which is like a huge thing, at least in my opinion. And I thought sweep and prune wasn't even good. Is sweep and prune fast? Faster than spatial partitioning? I guess you could do sweep and prune with spatial partitioning. Wait. Yeah, we use an octree. Efficient raycast. Anyway, I didn't mean to sidetrack you. No, I want to look up sweep and prune. I just normally don't hear about people actually using sweep and prune. I mostly hear about people using like off trees and stuff. Getting around the ON collision problem is kind of the core. Okay, if you have an ON collision, that's amazing. I don't think that's possible because that's testing no collisions. Sweep and prune collisions versus octree. Okay, spatial partitioning algorithms, what are the advantages? Does anyone talk about sweep and prune here? Sweep and prune is great if you have objects that are not very dynamic. They have to stay in the same order for it to be efficient. Quad/octrees are great if you have a low number of objects. Sweep and prune along one axis. Evaluated both on a couple of platforms. Found that moving objects clustering on top of each other as they moved around the sweep and prune implementation caused too much sorting and overlap callbacks every frame. It was crippling my platform. And end, I chose the dynamic bounding tree based on the implementation of box 2D. The structure is now paired with an overlapping pair cache. An object moves, if it doesn't travel outside of an axis aligned bounding box, it doesn't change. That's nice. Once you make that list, which is faster than you think and be parallelized easily, it's ON. Yeah, once you make the list, but if you're updating it, that's the slow part, is updating the list. If you're sorting by one axis, yeah, but sorting by multiple axes is way slower. That's the huge issue. And it's not like, it's when they change, what's it called? It's when objects pass each other that they switch in the list and the sweep and prune, right? Which is like all the time with dynamic objects and things. Oh yeah, so I don't want to read this pointer each time. I guess I could store the pointer here so that I can just read it. I could also just store a direct pointer to each position. Just because I want this to be as fast as possible. Make it work, then make it fast. I already have it working. Now I'm working on making it fast. Yeah, so I think the fastest way wouldn't even to have the rigid bodies here, would be to just have pointers to the velocity and the position. And then maybe the mass too. Then it doesn't need to add. That won't be any different. It will be. So right here, it's reading a rigid body pointer. Body pointer position is the same as position. No, it isn't. The first body call here is just reading a pointer address. A dereference and an offset is the same speed as a dereference. There's a whole other reference though here, because you're getting the body before you even call body position. So you have a whole other reference that it gets before it even gets the object, and then it gets the position pointer from that. And and the offset, and in x86 the offset move pointer call, as far as I'm aware, isn't as fast as the normal. Like the flags you have on the move calls do make a difference, even if it's super tiny. Now that is premature optimization. So you're talking like one cycle. Yeah. One thing I'm looking at though is if the mass. So this is going to actually use more memory because the pointers take way more memory than just storing the rigid body, which makes me wonder, what if instead of storing the pointers or anything here, what if I did the whole just rigid body right here, and then I had another array that I actually just stored the positions and velocities with for temporarily for looping through this. So that way it reads them from a list. It's cache friendly. Yeah. You know what? Screw optimizing this. This is going to be something that I'm going to barely ever use. But yeah, I think fastest way wouldn't even be to loop through this joint array. It would be to create a buffer that just has all the data there, and then I can just loop through the buffer. Instead of guessing, you should really be profiling and stuff. Guessing at micro optimizations is probably a waste of time. Look, I'm gonna be real. Most of the time when I'm optimizing this stuff, I'm right on. Before, when I was doing those 10,000 particles, do I still have the comment up here? No, I don't. It was running at 0.3 ticks per second, and I got it up to 50 by optimizing it. But yeah, there's multiple reasons why that would optimize it. First of all, just putting it all in a buffer right together makes it cache friendly. you're reading all the data directly in a row, and it's barely any data. Reading it from the rigid body and the objects here spreads it out a giant amount. Then there's the whole other thing of there being a whole bunch of references here. And then, like, you gotta realize once you're on 64-bit too, like 64-bit pointer calls are actually slower than 32-bit pointer calls. It's fucking horrible. I don't know if you're talking about benchmarking, but have you benchmarked like 64-bit versus 32-bit? 64-bit actually comes out as being slower in a few things. But yeah, how much of a benefit would that be if it didn't have to read the velocities from these pointers? Yeah, screw it. Surely the velocity's in the body though, right? Yeah. That's the whole idea though, is so that you don't need to read the body and then read the object. Body velocity is going to be the same as velocity. It is, except for getting the body first and then getting the object pointer from the body. It's got to do those it's got to get those pointers first. Alright, here we go. So this is the first main part of the actual joint physics. Oh, this is Y. So this calculates the next position for extrapolating the velocity in the future, or one frame into the future. Calculates the differences between those positions. That gives us the difference of where we need to move each body to keep the joint connected. So then repeating that over and over again in a bunch of iterations and steps is the integration. Making an NES game right now. 6502 has no easy way to pass parameters to a function. Wait, can't you just assign a set of memory as a stack and just do that yourself? Just say this part of the memory is the stack, this part of the memory is the stack pointer, and then you just can't read from the stack on 6502. But like, there has to be memory that you can read and write, right? You can push and pop, isn't that all you need? Wait, isn't popping reading? Alright, so the divide by length normalizes this. The minus joint's radius keeps the joint away. Maybe you should try doing these things with 3 registers. I've reserved the setting global variables to pass function parameters and basically make a global union of parameter structures to save on memory. That's the global variables to pass function parameters was basically what I was talking about. Create your own stack. If the stack doesn't work the way you want it, make your own. So then I gotta multiply this by the joint strength. I don't know if I want to do mass in this, because the mass actually adds a fair amount to the calculation, dividing the mass and doing all this, but it barely adds anything. Like, realistically, whenever I make these things, I want them to basically behave as one solid object, which is going to have one mass. So I don't think I'm going to do mass in this joint physics. It also seems like a really easy way to make it unstable is making certain parts move with way more force than others. Alright, that's it. Joint solvers often have problems like that. A heavy body connected to several light bodies in a frame will just freak out in physics. Yeah, I had to clamp it to fix that, but it made it incorrect as far as I'm aware, clamping it. So like the more correct solution I see is to just all use them with the same mass, which, like I said, basically should be how it is anyways. I'm thinking also, instead of count, I'm gonna do I don't know if I want to do count or size, but basically like number of active count, so that way I can scale up how many are actually active. Alright, sweet. So that code for the joints is actually nice and small. That's very cool. Alright, now I need to optimize the rest of this and delete all this old code. But yeah, actually, part of my inspiration for creating one of these physics engines was using Unity and Unreal Engine and always having fast-moving objects fly through each other no matter what constant collision detection or whatever settings I turned on. And I believe that was physics. That shouldn't be happening. Continuous collision detection usually has never failed me. I don't know. Have you tried it with mesh colliders? I'm actually looking at optimizing these parts now. Yeah, every which way. I have had issues with mesh colliders. God damn it, brain, don't forget what dot product is. Were they concave meshes? No. It was like a height map, like a terrain. It was an issue where the triangles met, like at corners. And like the opposite thing happened besides it passing through is sometimes like, so one of the games was a golf game and the golf ball would be rolling along the triangle mesh and it would go across one of the seams where two triangles meet and the golf ball would fly up in the air like it basically like bounced off a of like a ridge or edge that was going almost like straight up. Even though the mesh collider, I'm pretty sure it was precision issues with the mesh collider, but like it's still a huge bug. Any seam in a mesh or any seam between box colliders would do that. Huh. eventually solved it by banding all that and scripting the ball's movement. Scripting is always like the finest. It's basically the way you get things absolutely how you want them. Oh boy, this is quite the code. And I'm not sure I'm using all of it. Let me read through this. Just sphere cast where you want to go. Oh wait, I see what I was doing here. I was using the position here before it had moved. Oh wait, I actually want to keep doing that. That's correct. Alright. Taking a address of something and then dereferencing it. Yeah, I'm using that as a trick to cast a Vec3 to a Vec2. Okay, it's a waste to calculate each of these velocity lengths twice. Instead, what I can do for this move 2 is I can calculate the velocity length and then use that to normalize. Mass difference, dot product, bounce, friction. Actually, all of this looks oh yeah, this needs to be optimized right here. That's a mess. Wait, did I just have the bounce enabled for 1? Oh my god, I only had it bouncing on the x-axis. Oof, that's an unsafe cast. If you ever compile that on a system that adds padding between the struct members, it'll fail. Yeah, you can predict C padding though. That's the nice thing about C. Also, I'm fairly certain, I know GCC has it, MSVC should as well, is that you can actually add preprocessor commands to say how you want it to be padded, if you want it to be packed together. But as far as I'm aware, it uses the same as like OpenGL, GLSL, STD. I think it's called STD 140 or something like that. modifying the padding can make it much slower. Not on most desktop platforms that use like even 64-bit platforms are still based around 32-bit instructions, which is such a joke, but it's part of why you don't need to even worry about 64-bit alignment. Let me see what this bounce code is. Okay, so wait. And the scale, so this is going to be the mass scale. Damn, I got lots of floats for this. GLSL does all kinds of magic with swizzling and stuff. Yeah, I don't know if it's really magic. It's more just really giant processors that have room for tons of different instructions. Or more like tons of the same instruction. Oh, okay, I feel like I can rewrite this. I feel like that is not written the best way it could be. Actually, no, I don't know how. There's no way else I can do this. I would do like bounce minus bounce divided by would be the way. Not sure if that's premature optimization as well. This part as well is just the collision response, which is called like barely ever. It shouldn't be called even close to as much as everything else, so it's not really much of a worry for optimizing. Oh, I can't scale the normal because it's used afterwards. Oh, yeah, okay. There, that looks much better than down there now. There we go. Alright, now I also need to look into adding the on-collision function response, and I can take out these joint variables. Aren't needed anymore. Oh, I should also add a trigger for potential colliders. So like if a collider, I should also add a collision response function here. Because then I could do like triggers and stuff when people run into colliders. I still haven't laid out how this on-collision function is going to be though. On-collision, rigid body, pointer to rigid body 2D is the first argument. Oh, actually, you know what? I think this is correct to use AP instead of this. Alright, so there's a collision. I don't think it needs the distance because it's obvious that the collision is below 0 between them. Just needs the collider. And then I think that's all I'm going to do. If returns true, no collision response is done. So this can make it so that if it returns true, you can implement some custom velocity or something. Actually, this can't return true, it can only output. You know what? I think I'm good with this. Alright. I'm gonna set this null by default. Oh yeah, I also gotta add custom collider to this, and I also need to make this sort the colliders. So if on collision oh wait, this is wrong. It's not supposed to be rigid body 2D. Oh wait. Yeah, it is. This is supposed to be RB. So let me think. Is this passing in the right normal? So this normal is towards. So this is actually pushing towards. Oh god, that's really bad. So what is this collider 2D normal? Yeah, that's the position, or that's the direction to this position from the collider. Just like this. So this is wrong. This is correct. This is wrong. Oh my god, how has this not been glitching out? Wait, I'm so confused. That does the position minus the collider. Yeah, oh my god, how was that working before? That would kind of explain why my objects were going through each other sometimes when they actually, like, that's actually amazing that they weren't flying through each other all the time. They were only going through each other when I put them out inside each other. Like they spawned already colliding. Alright, so now I just need to flip the normal right here for this. Hell yeah, there we go. Alright, so now I've implemented the onCollider function. Just a few more things I gotta do. I gotta do a custom collider. I need to sort the collider into the grid. And I also need to add a function for updating that if the collider moves. Actually, I can add it to the transform update. And it'll automatically update. Oh yeah, and then I want to implement try and implement a simple renderer for the editor, so that when I select one of these objects that has a rigid body here, or a collider, then it actually outlines the where the collider is. Anyways, I'm gonna go get some water. Be right back. Alright. Okay, so one thing I want to check. I don't remember if transform update is called for all enabled or just transform update calls. Enable, where's enable? Add transform update. Okay, yeah, so it doesn't call this. Oh, so this is a good thing to consider. So I can either have the collider automatically update, potentially making it a lot slower if the collider is an object that's moving in real time, or I can make it manual so that each time I move a collider, I need to call that. Update transform. Alright, so now this is called whenever the transform's updated, and it'll use that to update its position and stuff in the grid. You know what? Actually, because this is also customizable, I could actually disable transform update if it ended up being such a... So I can implement this, and then if it ends up actually being something that slows down somewhere, I can actually modify this function pointer to stop it from being called. So that's actually awesome. Okay. So then each of the times here... I wonder, does it automatically call transform update? No, it doesn't. Okay. Alright, so I need this code right here where it calculates the position in the grid. Wait a minute. Never mind. I was going to say I could optimize this transform update loop by checking if this is 0 before locking it. Actually, UC does not equal 0. See, I don't know if that actually makes it slower though. Because then it's checking if it's not 0, then it's also doing it in the for loop. And this is just flicking a boolean on and off, so yeah. Actually, no, these are checking booleans, so keep that. I should call this stream premature optimization. Okay, so another thing I'm also going to need to do here is calculate if the bounding size of the collider is bigger than the supported grid gap size. Physics 2D max size. Max grid object. I don't know. Oh, man, I calculated this before too. What did I do? Physics 2D grid gap. So if I've got a sphere or circle or whatever smaller than the grid gap size, or radius is smaller than half, and let's say it's searching from here, it's going to be correct in the max sizes. It's here, one away. Yep, so the max size is half grid extent. Okay. So I guess this depends as well what collider type it is. Is the radius, right? Yeah. Okay, so if the radius is bigger than half the gap, then it's outside the grid. Now grid ID 0. Here, otherwise, alright, here we go. So if the grid ID hasn't changed, okay, so I'm actually going to need 2 of these states. I'm going to need 1 to signify disabled and outside of the colliders array, and 1 for enabled. Okay, cool. So now here, I actually have to just call this disable code. Awesome. So now our collider is added to the acceleration grid. Now I've just got to do custom collider. So let's see, what would that function look like? It's going to be done with a function. So actually, I don't know if I want to have a normal function or if I just want to have a distance function, and then I can automatically calculate the normal with the derivative. I think I'm just going to have a distance function. So what would that look like? Probably a position. And output a float distance, yeah. Okay, that's really easy. Alright, now I just need to implement the custom distance in the normal function here. If okay, so now so I gotta decide what precision. I'm just gonna do really precise. Or maybe I should add that as an option right here. Alright, so now we can calculate the normal with this derivative and then normalizing it gives us everything we need. Alright. Awesome. Okay, everything is set. Custom colliders. Our test here no longer works because this joint system isn't how it works anymore. But I should be ready to just go ahead and start working on a racing game. I might do that tonight. I don't know, we'll see. A little 2D car racing game to test out the joint physics. Should be fun. I'm sure, I'm just thinking though, I'm sure I'm gonna find another bug here when I'm testing this. Nothing's ever bug-free. The thing that really weirded me out was how I had this positive the whole time, which would have actually caused collisions to push the position inside the other colliders. I'm so surprised that didn't cause them to get stuck anymore, but whatever. Anyways, very happy with this. So happy that like Like, I was actually questioning at times whether or not I was going to get this joint physics working, so getting it working, so awesome. Very happy with this. I hope everyone else loved watching this too, or at least enjoyed it. I think programming physics is one of the kind of unique things to do because it's so like responsive. You basically get to see the results of your programming play out in front of you. Anyways, that'll be the end of my stream for now. I might be back in 2 hours or so tonight for a stream. If not, I'll be back tomorrow. Thanks for watching. Have a good day wherever you are.